Next, we'll review writing numbers in scientific notation. Scientific notation is used in science courses such as chemistry to avoid writing very large or very small numbers. It also helps us to put these large or small numbers into a perspective that we can understand. For example, let's consider the number of hairs on a human scalp. Humans have an average number of 1 times 10 to the fifth hairs. What does this mean? This means we have a digit in the ones place, and then we have a multiplier that's 10 to the fifth. This actually can be expressed as 1 with 5 zeros behind it. Each hair is about 8 times 10 to the minus 6 meters in width. What does that mean? 8 times 10 to the minus 6. It's 8 times a multiplier. That is a very small number. 0.0000008. That's what it means to express 8 times 10 to the negative 6th as a decimal number. Numbers written in scientific notation have two parts, a coefficient and a power of 10. For example, 2400 written in scientific notation has a coefficient of 2.4. Those are our significant digits in the number 2400. And a power of 10, which helps us to get rid of the zeros we don't need. It helps us to get rid of the parts of the number that we don't need, the parts that are non-significant, and compress that part into a multiplier that we can use to keep our number together. So write the product of the coefficient multiplied by a power of 10 to get the scientific notation. So 2400 expressed in scientific notation is 2.4 times 10 to the third. To express 2400 in scientific notation, remember there's always an implied decimal behind a number that doesn't include one. We need to move this decimal point to behind the first digit in the number. So let's go ahead and do that. And let's keep track of how many places we move that decimal point. 1, 2, 3. We have to move it 3 places from behind the last number, the ones place, to the first number in our whole number, in our entire number. And so we've moved it 3 places. So that means our coefficient times our power of 10 would be 2.4, which is our expression of our significant digits, times 10 to the third. Remember, we moved it 3 places, and that's our power of 10. That's our multiplier that keeps track of those insignificant values that we don't need. Next, let's express a decimal number in scientific notation. For example, here we have 0.00086. This is a very small number, so we can use scientific notation to express it in a more tangible way and to keep our large number of digits down to a minimum. So to do this, we'll need to find our coefficient and our power of 10. Our coefficient is the significant digits in our number. And in this case, we have 2 significant digits, which are 8 and 6. Our power of 10 is identified by moving the decimal place until it's behind the first significant digit. 1, 2, 3, 4. We move it 4 places to the right. And because this is moved to the right, because it's a small number, less than 1, we have a negative exponent. So our significant digits are 8.6, and our multiplier times is 10 to the negative 4. So we multiply it times 10 to the negative 4, which keeps track of the place where our decimal point would lie behind the first significant digit. Next, we'll explore some positive powers of 10. 1, as our standard number, could be expressed as 1 times 10 to the 0. So we would have no multiples of 10 here, and 10 to the 0 is 1, so 1 times 10 to the 0 would give us 1. 1 times 10 to the first would give us 10. So we would just have one multiple of 10, 1 times 10 to the first. 100 could be expressed as 1 times 10 to the second, which could be expressed as 10 times 10. 10 times 10 is 100. 1 times 10 to the third would give us 1,000. So 1,000 can be expressed as 1 times 10 to the third. And that's also 10 times 10 times 10. That's 3 tens. 10,000 can be expressed as 1 times 10 to the fourth, or 10 times 10 times 10 times 10. So notice that this is the number that we would have to move the decimal place. So 1 could be expressed as 1 times 10 to the 0. We don't move the decimal place. 1 times 10 to the first, we're moving the decimal point 1 time, 10 to the first. 1 times 10 to the second, we're moving the decimal point 2 times, 10 to the second. 1 times 10 to the third, we're moving the decimal point 3 times, 10 to the third. And 1 times 10 to the fourth, we're moving the decimal point 4 times, 10 to the fourth. Here are some negative powers of 10. For example, where our standard number is 0.0001, we can express that as 1 times 10 to the minus fourth, or 1/10 times 1/10 times 1/10 times 1/10. This number is in the 10,000ths place. The tenths, the hundredths, the thousandths, and the ten thousandths for our decimal number. 1 times 10 to the minus third would be expressed as 0.001, and that would be equal to 1/10 times 1/10 times 1/10, or 1/1000th. 1 times 10 to the minus 2 is 0.01, and that could be expressed as 1/10 times 1/10, or 1/100th. Notice that's in the hundredths place. That's 1 out of 100. 1 out of 100. Then we have 1 times 10 to the minus 1, which is 0.1, which can just be expressed as 1 over 10. It's in the tenths place, and that's 1/10, 1 out of 10. Scientific notation helps us express extremely large and extremely small numbers in a more concise way. For example, the diameter of a chickenpox virus is 0.0000003. Meters, or 3 times 10 to the minus 7 meters. Notice this number is the 3 times 10 to the minus 7 is much easier to read and more concise. Here are some more examples of why we would need scientific notation. For example, the volume of gasoline used in the United States in a year, 5 times 10 to the 11 liters. The diameter of the Earth, 1.28 times 10 to the 7 meters. The average blood volume pumped in a day, 8.5 times 10 to the third liters. Time for light to travel from the sun to the earth, 5 times 10 to the 2 seconds. The mass of a typical human, 6.8 times 10 to the first kilograms. The mass of a stirrup bone in an ear, 3 times 10 to the minus third grams, and so forth. So it helps us to express extremely large and small numbers in a more concise way. Calculators can vary on entry for scientific notation. If you need assistance expressing scientific notation in your calculator, please see your instructor for help. Let's have a learning check. We'll express each of these numbers in scientific notation. Let's analyze each problem and convert them to scientific notation. First, we have 64,000. How do we express that in scientific notation? So what we want to do is observe that our decimal point would be right here on the right. We want to move it until it's behind the first digit, the first significant digit in our number. So let's move it to the left. 1, 2, 3, 4. 4 places. Okay, so we've moved it to the left, which is going to be a positive move, and so we'll need a positive coefficient. So this will be 6.4. Those are our significant digits here, times 10 to the, and we moved it 4 times, so that's 10 to the power of 4 times 10 to the fourth. 0.021, and this 0 here is just to help us see the decimal point better. 0.021, expressed in scientific notation, we need to move the number to the Right. We move it to behind the first significant digit. We'll talk about significant digits later on. But the zero here is just a placeholder. Our first significant digit is the 2. So we want to move our decimal to between the 2 and the 1. This requires us to move it 2 places to the right. Since we moved it to the right, that gives us 2.1 times 10 to the negative 2. If you have a decimal number, your exponent will be negative. We've covered many concepts in this chapter. First, we covered what are chemicals, the scientific method, how to study chemistry, and some key math skills. Feel free to go back and review these skills. Next, we will cover some worked examples.